Two mathematicians and two musicians come together on a project. It sounds like the start of a joke, but it actually has pushed forward the idea that artificial intelligence can be a musical collaborator. It'll be demonstrated with the Louisville Orchestra this weekend and new composition by Adam Schoenberg, Automation. I'm Colleen Phelps. We'll talk to mathematicians Kathryn, Leonard, and Ghassan Sarkis later in this interview. But first, Adam Schoenberg and cellist Yves Dhar talk about automation.
I read a little bit about the history of AI in music and was surprised to see it goes back to really the beginning of AI. And in 1951, Alan Turing produced having an AI produce lines of music. That's 1951. That's a long time ago. And do you feel like it's still kind of the next frontier for classical music? Let's start with Yves.
Well, AI has been around, for some time, as you mentioned, and I just think it's really a question of what level of artificial intelligence, what activities they're doing, and I also think there's a question of how accepting that we are as humans to allow certain things to take place. Yes, we know that the technology has been there. To what level and to what output is it there? I will be the first one to tell you I am not a full level expert. Obviously, in doing a project like automation, I have done background information, background research, and looking into where AI is. But I think there's just always been this fascination with robots taking the place with humans, first in the sense of helping us, and then in a sort of an appeal to our ego, if their ability surpasses us, replacing us. So, those questions have been there. I just think now with the prominence of things like Alexa and Siri, who are now just commonplace. We regularly, ask these digital assistants, and they're listening in on us, and they do things. Or customer service representatives. We've all been on the phone, and please press 2. Sorry, that answer did not. We didn't get that answer. Any of those types of things that become so commonplace that it really takes a very advanced robot and something that is really infringing on what has typically really solely been human territory, which are the arts, anything creative, anything to do with expression and soul, that now all of a sudden, hey, can AI actually do this?
Adam, as a composer, was that something that you've always been kind of willing to interact with and jump into, or is it a little bit of a scary concept to work with AI or AI as a concept?
For me, it was definitely a fascinating concept. Certainly, it can be frightening in the sense that what the AI that the Occidental College and Pomona College math department built for us far exceeded expectations in the sense that it did surpass certain technical abilities of what could be written, in the sense that a certain section of the piece became actually impossible for a human cellist to perform at tempo based on what the AI wrote. But it's sort of projecting into the future, just like, world records are always broken every generation. Athletes get stronger and faster. And so ideally, musicians are also going to get better and be able to do things they weren't able to do prior. Just like Stravinsky's Rite of Spring from 1913, when he wrote a really high opening bassoon solo, he wanted it to sound grotesque because it was out of the range of the bassoon, but people today now make it sound beautiful. So he was once quoted at saying, every 50 years, I want the piece to be raised a half step so that it continues to sound gross. So, and for us, and in this concept, AI has been around for a long time, but really, this is a very sort of philosophical and conceptual piece in terms of the concept. And so the idea was, will the AI surpass the human being? Can we have it learn music in a very specific way, and not in a way to replicate, but to actually digest and then create something new based on the existing material. And that's to me what was most fascinating, the output.
From there, I think the next logical question is, how is AI part of this concerto? Talk a little bit about how does the piece work?
Well, I mean, as Adam mentioned, when we first approached this, we were first approaching it conceptually and philosophically. We didn't come in saying, "Hey, we want an AI learning machine to compose music." I wanted Adam, who's a dear friend of mine, an amazing composer, to write an awesome piece for me to play. That's the beginning of this, before automation, before holograms, before electronics, AI, anything of that. And that's what this is at the end of the day. It's an amazing piece that is expressive. It explores certain things, and it just happens to involve tech. So as far as the AI components, as we were developing it, I think Adam and I, we said, look, this is exploring that intersection between humans and artificial intelligence. It's exploring the intersection between concert hall and film music. It's exploring that intersection between analog and digital. We can't talk about these subjects without actually having some sort of artificial intelligence. So Adam, I was trying to figure out a way of how to incorporate this. And Adam, on his own, he was having conversations with the comp sci department at Occidental. And Adam, I think it's probably more appropriate you talk about that experience of how we ended up getting Agnes into this project.
Yeah, so basically at the college over the summer there was an institute for technology, essentially, and that's when I became more friendly with the chair of the computer science department, Kathryn Leonard, as well as another colleague, Justin Lee, and we just sort of started having conversations in terms of what could a musical composition be that also embodies AI. And then Kathryn said, we can build a generator that will learn your music, and you can train it to learn your music in multiple dimensions. The most basic dimension, which has been done for decades, is, here's a C major scale, go learn it, and the AI will literally replicate it and play it back, but maybe at different tempi. And so there can be a certain varying spread of speed. But we wanted it to be considerably more sophisticated than that. So essentially in August, Kathryn Leonard and her partner Ghassan at the math department at Pomona built this AI learning machine called Agnes, which stands for Automatic Generator Network for Excellent Songs. AGNES, the acronym.
There's got to be an acronym.
Yeah, Oxy's famous. Probably like most liberal arts colleges, everything is acronym based. Like when you go to a meeting and talk to someone, you're almost speaking only in acronyms. So it takes a little while to understand the language. And so we fed Agnes 3 of my biggest orchestral pieces: Picture Studies, which is a 21st century pictures at an exhibition, fully orchestral. Then we sent it my symphony called American Symphony, and then we gave it a concerto so that it understood that there's an orchestra and a soloist. And it was my percussion concerto. And so between the months of August all the way through the end of November, it just spent months learning those 3 pieces. And MIDI data is much more sophisticated than what most people realize. So for instance, MIDI takes the tone, the pitch, but it also takes the dynamic volume, which is called velocity. And there's a velocity spread from essentially 0 being no sound to 127 being, a quadruple F, fortissimo. And so it takes all that dynamic range. The MIDI data also understands articulations, if it's a staccato, if it's an accent, if it's a tenuto, what type of expression is it, what type of phrase marking is it. So it gets a lot of information. So essentially can understand the orchestration, the color, the attack of a sound, and the overall decay of a sound, and then it processes all of that. So then in December, when the concerto was more or less finished, we fed it a very specific solo cello part of automation that we wanted it to learn. Oh, sorry, one step back. In December, we then fed it a solo cello piece I wrote years ago that Yves performed called Ayúdame, so that it understood we've now learned my music from an orchestral sense, from a color sense. Now we're going to learn one singular instrument that I wrote, so it gets my voice in that degree. Then after it learned the solo cello piece, we fed it this one section of the concerto called learning mode, which we wanted to see exactly how Agnes was going to learn this material. And I was not going to alter that material. Once Agnes learned learning mode exactly as written, we then embedded learning mode in terms of what Agnes learned in the score without altering it. And that's exactly what you'll hear. So when you go to the concert, Yves will begin playing what I wrote for him.
Human composer Adam Schoenberg.
Yeah. And then a couple seconds later, you'll hear this processed cello that Yves, of course, also played. We went to a studio and recorded it, but he's now playing exactly what Agnes wrote. And then through sound design and electronics, we ran that same information through synths with a synth programmer that I work with. And then our sound designer helped process and sort of master that sound. We auto-tuned it to make it sound very mechanical. And then what you hear within that section is this dialogue between human cellist Yves and AI cellist Agnes. And then you sort of have this two-part concerto that happens, and then that segues into the next section, which is dubbed battle mode, which is really sort of the conceptual philosophical moment of the piece of our relationship. You know, our log line is our complicated yet codependent relationship with technology. And now Agnes is saying, hey, I'm here, Yves Dhar, and I'm not leaving. And then they enter this intense moment of music.
I'm Kathryn, Leonard, professor of computer science at Occidental College.
I'm Ghassan Sarkis. I'm a mathematician at Pomona College.
So tell me a little bit about yourselves and your background, both in STEM and if you have any background in music.
So I'm a mathematician and I study geometric modeling to do tasks to understand the world. So most of the work that I do is to understand shapes of data, but also shapes of objects, like two-dimensional and three-dimensional objects. And that's actually, that last part is where most of my work has focused. So because of the sort of object application, I've worked a lot with computer graphics people and digital artists, some computer vision projects, things like that. And because of that, I've kind of edged onto this computational creativity realm that I would say that this project fits into, that we're talking about today. One thing that I like to emphasize is that the work that I'm doing is meant to help inform and also replicate human perception. So I do a lot of human perception studies to see how well the models that I'm building are matching with what humans think. So let's see. So that's kind of the technical part of that's what I get paid to do. But then in terms of my musical background, I actually come from a very musical family. My parents met in 8th grade at band camp. My mother has a graduate degree in piano performance. My sister trained as an opera singer for some amount of time. I was raised playing the piano, but ultimately veered towards dance more than music. And I really haven't thought about music in a really long time, but there's some sort of foundational childhood experience under there.
And we do have a piano right here that she occasionally tickles.
And your background?
So I'm trained as a pure mathematician, which means the math that I do has absolutely no bearing on the real world. But because I know her, I get the benefit of seeing how math impacts the world and how it interacts with human perception and human decision making, which gets me very interested and jealous. So I've had the advantage of learning free of charge from her and from her projects and from these conferences that she attends, all about the gratification of seeing that theory interact with the world. And as a result, I've got to tinker with lots of my own projects at a much less sophisticated level than Kathryn's, but still at an entry point that I would not have been afforded otherwise, including generating playful interactions with humans like Twitter bots or email bots, mostly textual, and some even things I ended up getting paid for, like supervising student projects that ended up being in the machine learning realm that I would have had no business doing had I not been exposed to those kinds of applied math projects that Kathryn is immersed in. And I have zero musical background. No one in my family, we are all exceptionally skilled at missing every note in every song that we try to sing. Doesn't stop us from singing, but I probably have, let's say I have the outsider objective perspective to music. I'm not influenced or biased by actually experiencing it myself.
Well, with this project now, you do have a musical background. Kathryn, you said something that really struck me, that your work is seeking to understand the world. And I know that's something that is across the board with science and the study of science and experimentation, but it's also something musicians and composers talk a lot about with the work we do, about how we're, reflecting our experiences in the world. Slightly less broadly than that, though. What I understand the creative goal for a composer and a musician to produce a concerto. Scientifically, what were the goals from this project, or the hypotheses or objectives?
Yeah, I mean, my goals, generally speaking, in this realm are to develop tools that are useful to humans and also grow our understanding of the world. And so this project was really interesting to me because I hadn't worked with music data before. And so I don't have any sense, like from the data science-y kind of side, of what the important features were going to turn out to be in music in order to get a reasonable facsimile. And so that was growing my understanding of music. Of course, this is probably an understanding that musicians have from other sources. But then also to develop a tool that's useful to humans. I guess I would say that I view these kinds of computational creativity projects as being humans and technology collaborating together. So answering a question you didn't ask, I wasn't at all thinking of this project as trying to build a thing that could replace a composer, a human composer. I feel like a lot of the importance of art and music is that it's really humans communicating with humans. And so I feel like that piece is completely lost if I build a thing that can make a painting that you think a human possibly could have made, isn't the same thing as a human chose to make it. And you can wonder about why that was the thing that was chosen to be made and things like that. So I feel like that's a loss. So anyway, to answer the question you did ask, I was interested in building a tool that could collaborate with a composer, which I would say that Adam collaborated with us, and we collaborated with the AI, who collaborated back with us, and then we collaborated back with Adam.
So give us the description, and I'm hesitating, but I'm just going to come out and say, speak to me like I'm 5. And if you could just explain what you created.
Yeah, so Ghassan has come up with a pretty good tagline. So I'll go first with the kind of maybe the technical description. So what actually we built is called the Generative Adversarial Network. And what that is kind of two separate AIs, if you will. One of them that's generating music, and the other one who's trying to figure out if music that it sees is real music or fake music. So I might have called this, if I had invented the network structure, a generative collaborative network. but the sort of common analogy is these two networks are sort of fighting against each other for dominance. So each side is trained separately. So the discriminator side is shown a bunch of music that's real, actual music. And it's shown a bunch of basically static, and it learns to distinguish what real music looks like up to a certain point. And then on the generative side, we showed the generative side 8 notes or 8 beats as an introduction. And then its job was to try to predict from real pieces of music what the following note or beat structures would be. So these two sides were being trained kind of independently of each other, and then they get put together in a competition, which is where the adversarial part comes in. So the discriminator is trying to catch the generator as being fake, and the generator is trying to fool the discriminator that it's a real human composer. And I think really one key piece to our success with this was that instead of just training the discriminator, the one who's trying to catch the fake music with static, we also trained it with outputs from the generator that weren't quite up to snuff, that didn't have the qualities that we were looking for. And so it had a much richer kind of view of what bad music looks like, or, I mean, I don't really even know what the definition is of real music versus fake music, but it had a much richer view of what we were not trying to develop than just static. So Ghassan has come up with a great pithy.
This was our morning walk data processing experience. Just, you go on a walk and you what's it called? It's not quite a brainstorming session, but it's when there are no bad ideas, even though we know later on that most of them are going to be bad ideas. But this is monkeys at a typewriter. But it occurred to me that this was fake it till you make it. So there's someone trying to fake it, and what they're faking is music composition. And there's someone who's an expert in forgeries who's going to tell that these are not real music compositions. And they learn from each other, which is where the collaboration versus the adversarial, this is a personality thing, but if they're both reasonable networks or reasonable programs, then they are learning from each other. The forger will become a better forger. They'll transition maybe from forgery as fake to forgery as manufacturing. And the expert on forgeries becomes better at telling what is not quite what we're looking for and what is the real deal, until not quite what we're looking for and the real deal blur the line between them. And the trick there, as Kathryn was saying, is to have the forgery expert be trained in precisely the kind of art that we want the forger to eventually produce.
Adam, is there any apprehension about the permanence of pre-recording part of a piece, where sometimes in this process you might be making changes or adjustments up to the premiere? Is there something, is it either freeing or is it scary to have something already permanent?
Great question. It's funny because my wife is a TV writer and a playwright, and when we first met, she was primarily a playwright, and we'd always talk about the process of bringing a piece to life, where for playwrights they have multiple round tables where they're reading and they get a sense of the ebb and flow of a piece. For composers, that never really happens. We basically show up the week of the premiere. In this case, we fly in May 9th and start rehearsing that week, and then you have 24 hours to make changes. So very little time to digest and process. In terms of this piece, and just in terms of my overall experience writing orchestral music, all the pre-records and the electronics that are finalized at this stage, I 100% know work architecturally and within our sense of time. So I'm confident that that will be fine. The orchestrations may inevitably change within the orchestra, and that's something I'll have to adjust on the fly, and will be prepared to do that. So less apprehension, more excitement in terms of this. If anything, I'm just nervous because it's my first time really employing a battery of electronics. And, this is not just an acoustic piece. We're amplifying the entire orchestra. They're running through the PA system. Yves is going to be amplified with his regular cello. The Haldorphone's amplified. The visuals. I mean, there's so many moving parts that we just hope that there's no, power outage and that the computers work.
I didn't even think about it.
Don't even mention that right there. I will say one aspect of the pre-record whenever I think the big sort of equalizer as far as deciding pre-recorded or not. Obviously, there's this second cello part, and the second cello part is not live. It's not a live AI being, but really more so than anything is when you involve anything with visuals. So film to score, Harry Potter scores, Star Trek, you need a click track. Otherwise, it needs to be synced. And in this case, it has to be synced very tightly because you will actually see this hologram playing the cello on screen. It's a special transparent screen. And so we want it to be as lifelike as possible. So for those parts, the concerto is roughly in two halves. The first half really dealing with this AI and cello back and forth interaction. And then the second half is much more of a traditional concerto. And it's nothing, it's just acoustic and live and impulsive and see what happens, in the sense that all the conductor and the orchestra and me, the soloist, get to make the magic happen.
The Louisville Orchestra premieres Automation with cellist Yves Dhar and Agnes, the artificial intelligence, this weekend.